All right, we have this question. Given that 2 to the exponent x plus 2 to the exponent x plus 2 is equal to negative 5y plus 20. So question number 1, express 2 to the exponent x in terms of y. The idea here is to solve for 2 to the exponent x. So taking down our equation like this, it's equal to negative 5y plus 20. So the idea is to break this one down like 2 to the exponent x plus 2 to the exponent x times 2 squared. This is equal to minus 5y then plus 20. So remember, we are solving for x, for 2 to the power of x, then we are going to take the common factor on the left side of this equation, which is in this binomial. You can see that there are two things that are common here, which is 2 to the exponent x. So when you take it out, you'll be then having 1 plus 4 then is equal to minus 5y plus 20. So of course 1 plus 4 is equal to 5. You can just write 5 here. Then you have to divide both sides by 5. Then you'll then have on this side 20 divided by 5 is just going to be 4, then negative y. So this is actually the expression for 2 to the exponent x in terms of y. So that's basically that. So number 2, how many solutions for x will the equation have if y is equal to negative 4? So they're asking about how many solutions for x. Is it 2? Is it 4? Is it 7? So we just need to know how many of them. I think the calculations must be done so that you see how many of those solutions we will have if y is equal to negative 4. Of course, when you have 2 to the power of x, you will have to use the simplified one instead of using this complicated one, because it is going to take you time to simplify once again and stuff like that. So we just need to substitute on this simplified one. So this is equal to 4. In the place of y, we put negative 4 again. Then therefore we of course have 8 here. Then x is equal to 3 and nothing else. So we only have one solution, and that solution is x is equal to 3. That you find it when y is equal to negative 4. So that's it. Solving the last question says, solve for x if y is the largest possible integer value for which this function will have solutions, which means there are some values of x that this may not have a solution, and there are some values of y that makes this one to have solutions. All right. Now, but we'll need to remember that our simplified equation of this was x to the power of x, which is equal to 4 minus y. So when they say solve for x if y is the largest possible integer value for which this will have a solution. But if you look at this one, this is an exponential function, right? The exponential function that is increasing. If you can view it graphically, you will understand that it is really going up this way. Okay, well, that means we also know that 2 to the power of x can never be negative, right? And of course, starting from 1, then depending on the value of x, that is, but this side is always going to be greater than 0. 2 to the power of x, no matter what the value of x is, but 2 to the power of x is always going to be greater than 0. So that means it also applies on the right hand side, that 4 minus y, in order for this whole equation to have a solution, then therefore this must be greater than 0, because there is no other way that this side could give you a negative value, so this one must also not give you a negative value. So on that note, you just have 4 minus y, that will force it to be greater than 0 for this to have a solution. So on that note, you can just solve the value of y, and taking this y to the other side, you will then have 4 greater than just y. That means y must be less than 4, but they say solve for x for which if y is the largest possible integer, and when y is less than 4, then the largest integer that is less than 4 is of course 3. So y is now equal to 3. So remember, you're solving for x. So when y is equal to 3, then therefore you'll be having something of this kind, minus 3. So we have 2 to the power of x, then therefore in the place of the right hand side you just have 1, then your x becomes 0 now, just like that. So the idea is to understand what makes this to be having a solution, and if it does, then these are the conditions that needs to be adhered to. So that is it.